Welcome to Maths Tech, your source of great learning. Today is the part 10 oblique 1 radicals. Sorry folks for not being able to upload new videos for quite some time, but now we are here with radicals. What are radicals? What role they play in the field of the mathematics? Let's begin. This is our radical symbol, this is our radicand, and this is our index. This is our index, this is our radicand, and this is our radical symbol or radical sign you can call it, and it is also called as a root. Now this radical symbol has got a value over here. What it could be? It is in the terms of a fractional exponent, and it will be a 1 by 2 over here. So remember one thing, that the index 2 is not written over here because of the principal square root, and it is usually omitted. So it has got a value of a 1 by 2, and similar with the cases of the cube roots. Suppose that we have a cube root, and 3 is specifically mentioned over here. So this cube root has got a value of a 1 by 3 over here. Let me write it again. A 1 by 3. And similar with the cases of the fourth root, suppose, and the value of this fourth root will be a 1 by 4. And if you want to know the value of the fifth root, a 1 by 5. And if you keep on going up to the 6th root, 10th root, whatever it could be, suppose that you have an 11, suppose that you want to find the 15th root, then the value of this a will be a 1 by 15, and so on. I hope that you are understanding this. Now this is your now this is now this is the value of the a square root, principal square root, and the value of the principal square root is usually 1 by 2. And remember one thing, I'm repeating that the 2 is not specifically mentioned, it is usually omitted for the principal square roots. Rest of the square roots, 3, 4, 5th, 6th, 7th, and so on, they are always specifically mentioned in the towards the left side of the radical sign. Now let me change the page. Now let's take the examples of the square roots we have. Suppose that we want to know the square root of 25, it will be, and the square root of the 25 will be 5. And if we want to write this square root 5 in the exponential form, it will be written as 5 raised to the power 2 over here. And look over here, that it has got a very interesting fact, that this square root is is actually the inverse of this exponent. Here it is 5 raised to the power 2, and it is 5 by 5. What you will get by 5 by 5? You get 25 over here. So 25 in the square root is the inverse of the exponent. Let's take other examples. Suppose that we have 36, and the square root of the 36 is 6. And now here 6 raised to the power 2, 6 times 6 is 36, as you know. So this symbol, this radical symbol of the square root 36 is actually the inverse of this exponent. Suppose that we have 64, which is a square root of 8, and it could be easily written as 8 raised to the power square. or 8 raised to the power 2. So it will be 8 by 8 times 64. Let's move on towards the cube root. Or let me take another example. Suppose that we have the 0.01 over here. Okay. So the square root of the 0.01 will be 0.1 and it will be written as 0.1 square over here. Interesting. Let's move on towards the cube roots. Now here the cube root of the 27 will be, what it will be? You can easily guess, it will be 3. And now here it can be easily written as 3 raised to the power cube. Because 3 times 3 times 3 will be equal to the 27. So again over here, the cube root is actually the inverse of this exponent 3 raised to the power 3. Suppose that I want to take the cube root of let's say -1. I think you must be getting towards 1i. Okay, let me tell you. The cube root of -1 will be -1. How come? If you write it as -1 in the bracket or in the parentheses, so -1 raised to the power 3, and here you can easily see -1, -1 and -1. If they are multiplied, what you will get? You will get obviously -1 over here. So the cube root of the -1 is -1. Let me take a fractional part. Suppose that we want to find the cube root of 1 over 125. What it will be? You can easily guess. It will be 1 raised to the power 5. 1 and now the 5 raised to the power 3. And what you will get? 1 over 125. So again, your cube roots or your radical symbols are the inverse of the exponents. Now let me change the page. Now we shall move on towards the fourth roots. Fourth root of 16, what will be? Yes, please guess. Yes, it is 2 over here. And if we write it as 2 raised to the power 4, you can easily see that it will be written as 2 times 2 times 2 times 2. And what you will get? 2 times 2, obviously 16 over here. And so on and so forth. So these are some of the introduction of the radicals. Now let's move on towards a real life example. Suppose that we have got an equation where I is equal to P over R. And here your I is your current in amps, current in amperes. This P is your power dissipation in watts, power in watts. And this R is your resistance, in ohms. Now, if your power is, if the power dissipation is suppose 3 times 10 raised to the power minus 3 watts, and your resistance R is 3 times 10 raised to the power cube ohms. And you want to find, and the problem is that you have to find the current in amps. What you are going to do, let me change the page. Simply, this is I. No, my pen is running out of ink. Okay, let me change it. I is equal to P over R. I over here, and P is, what was our P? P was 3 times 10 raised to the power minus 3 watts. 3 times 10 raised to the power minus 3. And what was our resistance? That was also 3 times 10 raised to the power 3 ohms. Now this 3 will be cancelled out with this 3. And what we are left with? We are left with only 10 raised to the power minus 3 and 10 raised to the power 3. Now what we are going to do? We will simply move this 10 raised to the power 3 towards the numerator side, and it will become 10 raised to the power minus 3, and here it is 10 raised to the power minus 3 also. Now when the bases are the same, the powers are to be added, so it will be 10 raised to the power minus 3, and here it is also minus 3. 10 raised to the power minus 6. Now the interesting thing is that this radical sign, which is a square root, because 2 is not mentioned over here, it will become 10 raised to the power minus 6 times 1 by 2, because this fractional exponent 1 by 2 is the value of this radical expression. So it will be easily 2, this 6 is divided by 2, and it will be 3 over here. So our current is 10 raised to the power minus 3 amps. So this is the end of our lecture, end of our video. I hope that you enjoyed this. Let me compile it again. If you like this video, please like, subscribe and share. In the next video, I am going to bring you the properties of the radicals that will help you in the future work. So thank you. Thanks for your time. Stay with us. Thank you.